Hey everybody! So, since the rise of quantum physics in the early 20th century, our cradled perception of a deterministic universe was, for the first time, questioned. Today we understand that the quantum world operates in a full indeterministic reality, which separates it from our comfortable world of the big, which we call home. But it is this messy combination of determinism where we are logically comfortable and indeterminism where we are not that I believe brings about some of the mysteries of our universe, like the notorious measurement problem in quantum physics. In this video, I'm going to give you my pitch in 3 postulates for why the universe should truly be indeterministic in full, from the smallest particle to the largest galaxy. This will not rest at the notion of a probabilistic universe, but rather will stretch to the point of an entirely new and cohesive system of reality to take the place in our hearts that determinism occupied for thousands of years. For the first time, this is the story of a full indeterministic world. Okay, so to begin with, how about we open up on the double slit experiment? It's a classic exercise in physics where you shine a beam of light onto a plate with 2 holes in it, allowing that light to go through and fall onto another plate in the back. Right? You with me? So if you do that, you get something that kind of looks like this, which can be mathematically described and measured to your heart's desire, etc., etc. But here's the problem. Now let's imagine that we start detecting which slit the light particles go through. If it goes through slit A instead of slit B, then hey, guess we know that now. When you look back at the plate, now you get your mind blown because the pattern changed altogether. Instead of the wavy pattern, now you've got 2 bright spots behind the slits, and that's the end of it. So, how can you change one pattern to another just by looking? My first conclusion was probably the same as yours right now, if this is the first time you're hearing about this. Well, duh, the detector must have been playing around with the particles, so its interaction changed everything. If you push a snowball down a hill, it's bound to change this or that. This mindset is what they call determinism, and it's super ingrained in our society and culture. How deep in the brain it is, though, I'm not sure. Whether it's societal or evolutionary, nature versus nurture is an open question for me. But here's the thing. I've always had a little tickling of a sense in my mind that determinism is missing something. Like since I was a little kid always. I'll give you an example. When I was a kid and started reading Lord of the Rings, I knew from my dad that the story was incredibly good. However, I had no idea about what the particular story was or how it would play out. Only that it was good. So I thought, there's a vast array of possible stories that I could read that would be good and vaguely have to do with elves, dwarves, and magic rings, which are some of the other things I knew going into it. But I didn't know what these particular stories would be, like in a specific sense, because, well, I hadn't read the books yet. I came to a shocking immediate conclusion to this. If I didn't know what happened in the books, even though lots of people did, then it's impossible for me to prove that the information even exists in the universe at all. Sure, I could go ask somebody, but that would immediately defeat the purpose because for all I knew, the information could have been created then and there to trick me into thinking it existed the whole time. So for that matter, anytime you ask anybody anywhere a question, you have no way of proving that the information existed beforehand, or if it was just then generated by some tricky cosmic mastermind who always wanted to keep you on your toes. Maybe you ask the question, and the answer gets immediately pasted into their mind so they can answer, and all the time beforehand, when they said they knew, their mind was in a state of thinking they knew, but being closed off to you about the specifics, which weirdly is exactly like the physical book itself. So for all I knew, I could be living in this weird universe where information only shows up as I access it. To be clear, at this stage I wasn't actually arguing for this madness that I'm going over. Instead, my realization was to simply note that this concept, which they call epistemological solipsism, couldn't be disproven and may very well be the case without my knowing. That is, crucially, empirical reality functions in exactly the same way whether epistemological solipsism is true or not. This is kind of a freaky concept, and my complete idea of later on took on a lot of inspiration from it, albeit with hopefully less solipsistic take on things. You'll see what I mean when you get there. Okay, so now that was the first thing I noted, okay? So now we're going to fast forward the clock a little bit to 2021 during the latter half of the pandemic. So how old was I then? I think 11th grade, right? Yeah, so, okay, that was me then, bored out of my mind, sitting at home all day, and my mind started to wander on how far could I take some certain concepts I was thinking of. Specifically, one of them which I call centric unfolding. Okay? So, the idea was essentially about, if I don't know something, how can I be sure that it exists, right? That's more of the epistemological solipsism. But then on top of that, there was a deeper component, which is not that if I don't know something, that implies it doesn't exist, but rather more the opposite. If I don't know something, does that imply that I'm connected to that thing? More like that. Or more specifically, as I really started to think about it, that maybe when I don't know something, it exists in all possible states at once. Or in other words, I would be on all timelines at once in which something happens, okay, that I don't know. So, little did I know it then, but this idea would eventually turn into my solution I'm going to present to you by the end of this video. But of course, let's try to work our way there. So, here's the original example that led me to thinking about centric unfolding back in 2021, etc., etc. I was thinking, wait for it, about dinosaurs. Yes, and specifically I was thinking about our mammalian ancestors in the age of the dinosaurs, so back in the Mesozoic. And I was thinking, what might they be like, right? Because, something that fascinates me is the Zoonomia project. I'm really getting off on a tangent here, but essentially the idea was it may be possible one day to know some of the genetic attributes of our Mesozoic ancestors. For example, if you were to literally pick one of them up and look at them, would they have dark fur or light fur, right? Because back in the Mesozoic, we would have been nocturnal. So just a natural question, are these animals that have dark fur or light fur? And I think we could safely say it's probably going to be dark fur because of the nocturnal environment, but technically we wouldn't know for sure. And that is the realization. So I said, wait a second, technically we wouldn't know for sure. So doesn't that technically mean that I could be on either timeline and I would have no idea? So for that matter, I might as well be on both timelines. And then from there I went to, wait, what if I am on both timelines? Like literally so, I'm on both timelines and I wouldn't have any way of disproving that. So that's really where we get the inspiration from epistemological solipsism, just in that one case. We wouldn't be able to disprove that I'm not on both timelines at once. So I could be on both timelines at once, where Mesozoic mammals had dark fur and light fur. And then the idea of centric unfolding itself is that you have this constant stream of updated information. So, obviously I have no idea about whether the Mesozoic mammal way back when had dark fur or light fur, so I would naturally suppose that I'm on both timelines at once. But then we could clone them, and I could hold it in my hands and look. And at that moment, I would know, and the information would exist relative to myself, and I would know where I am and which timeline I'm on, and so on and so forth. So at that instant, I would then join a timeline. But before then, I hadn't joined a timeline yet. I was just drifting off on both timelines at once, but then I joined a timeline once I looked. So that's kind of the thing. So it's the flip side of determinism. You can derive everything in the universe in the same ways you do with determinism, but with this version instead. And everything still happens and everything still looks the same way, but you have this funny idea where you keep joining timelines at every second, but before you join a timeline, you're on a bunch of timelines. So really the art of reality would then just be compressing reality continuously onto more and more specific versions by every time you gain information. And that's centric unfolding, which is, you're the center of your own timeline and you are unfolding the universe around you. And, that could be you're unfolding the universe, or it could be more like the universe is unfolding you. You got what I mean? You just, like traveling on a vacation. You just start going places. And then the universe just happens to go wherever you go. And that stuff. Okay, so this was all 2021. Now we're going to fast forward again to 2022. And I was just starting freshman year of college. And I happened to stumble upon this video right here. And that was the first time ever that I thought, wait a second. I couldn't explain it, but I had this little tingling of a feeling in my mind where I was like, wait, what if I'm onto something? What if, like, the stuff I'm talking about with centric unfolding is actually directly the phenomenon through which the quantum realm not only happens, but becomes intuitive? So, that was crazy for me. So, everything I just told you about you being on both timelines at once, or more specifically, all of the information you're unaware of is in existence equally relative to you, that would actually be the inspiration and the source of what would eventually be my second postulate. But before we understand the second postulate, we got to understand the first postulate. And before we understand the first postulate, we have to understand my concept, which I call the ethos. So we'll get there in due time. But first, let's talk about this. When that headline came out that the Nobel Prize for Physics in 2022 had been won by 3 scientists for essentially disproving quantum determinism with a really clever model of their own, I remember explaining it to my grandma and her fiancé over the phone about how I had been interpreting the discovery. My idea was simple. Reality has to come in pairs to make sense. So, okay, here's how I'm going to break it down. So, we have 2 friends, Bob and Alice. They entangle 2 particles, right? So that just means if one of them is spinning clockwise, the other is spinning counterclockwise, okay? And they take them. We don't know which one is spinning clockwise. We don't know which one is spinning counterclockwise. All we know is they're spinning opposite directions. So if you find one, you know the other is spinning the other way, okay? It's a bit of an oversimplification of how it works, but all of the fundamental properties go through into that. So it's a good way of explaining it if you haven't heard it before, okay? But they take these entangled particles, remember? So one of them is going one spin, the other has the other spin. Bob takes one, Alice takes another, and they move them to opposite sides of the entire universe. Okay? So see the situation here? Simple, really. Each friend is now holding a particle, and they're wondering whether they're holding clockwise or counterclockwise. Neither knows what they've got, but they know the other has the opposite one from them. Okay? So if Alice is clockwise, then Bob's got counterclockwise. But if Alice has counterclockwise instead, then Bob has the clockwise one. Now, lo and behold, Alice looks, okay? And she sees clockwise. So that means Bob has counterclockwise. The question is why Nobel Prize got won. Because they answered a big debate. So, okay, I'm going to break this down a little bit more. So you got Team Einstein, argued by, Einstein, who says that the information about which particle was clockwise and which was counterclockwise got created the moment the 2 particles were spun while they were still together. That way they could pass information without having to go faster than light. Because if they're far enough away, they're going to have to send information faster than light to close that gap fast enough. You know, see what I'm saying? Okay. Then against Team Einstein, okay, against all that, is Team Bohr, okay? He argues that the information about the particles doesn't exist until Alice checks. But after that, it does exist. Okay? Alright. So specifically, though, both states exist at once in this strange phenomenon called a superposition. Okay? This is a huge word. Until somebody checks. Alright? Then once the person checks, boom! You've got your collapse. So what was our example? Alice had clockwise. Bob had counterclockwise. The checking is done, and the superposition of all possible states at once, boom, collapses, and now you have one state. Alice got clockwise, Bob's got counterclockwise. Simple, straightforward, one state. But before that, Alice would have had clockwise and counterclockwise, superposition. Super, I think of it as like supernatural, and the position is like location, reality, whatever, like supernatural reality. Alice is clockwise and counterclockwise at once. Well, she's not looking, so she wouldn't see the superposition and how weird it would look or whatever because she's not looking at it. So it's like hiding outside of her radar that it's both at once. But then she looks, what? Oh, the particle's clockwise. What's randomly collapsed? Could have been counterclockwise, but it randomly collapses into clockwise, and then Bob naturally gets the opposite version. Okay. So, okay. But here's the thing. So remember, Bohr is saying that the superposition collapses the moment somebody looks for the first time. So, if Alice looks for the first time, then the superposition of both particles is going to collapse at that moment when Alice looks, according to quantum theory and specifically Bohr's interpretation. And what happens? Well, Alice looks, both particles collapse out of superposition, and both particles now are at their state. So maybe, what was it? Alice had clockwise, Bob had counterclockwise. But that happens while they're really far apart, so a beam of light wouldn't be able to get between them, and yet both particles collapse instantly at the same time, and so information is traveled faster than light? Okay. This made Einstein really worried, though, because everybody said the information between the particles faster than light, which is really bad news for his theory of relativity. I can imagine that Einstein would have thought about what this means for the theory of time. I mean, think about it. If Bob checks 10 minutes after Alice, then since they're on opposite sides of the universe and so far apart, a beam of light can't get between them in time. Einstein's theory tells us that whenever this happens, time loses its order. That is, neither one of them checked first, because the one who checked first depends on who is looking. Okay, see what I mean? In one scenario, this is all Einstein's relativity stuff, but I'm gonna break it down a little bit so you can hopefully understand it. Okay. In one scenario, somebody flies by in a rocket ship, and to them, Alice checks first. But to another person in a rocket ship, going in a different direction, Bob checks first. Okay, Einstein says time depends on who's looking, and kind of more instead of what's happening. So we have no place to root the quantum collapse, objectively speaking. What I'm saying is that he always says it's physically impossible to find who checks first because there is no first. Who checks first depends on who you're asking if they're too far apart for a beam of light to get between them. In one version, Alice checks first. In another version, Bob checks first by however much time difference you want. So this is kind of a disaster because if there is no first, what are we going to root the quantum collapse to and then say that's when it collapsed? But early quantum physics made itself very clear, so apparently that wasn't the end of the world. Just pretend relativity doesn't exist, was the mindset. I mean, guess it works. So this Nobel Prize was that Bohr's team won, and Einstein was wrong, apparently. Okay, so of course this takes the world by storm because we're used to Einstein was totally right again headlines instead of Einstein proven wrong headlines. Even because of this, I think outright denying Einstein is a risky business, but technically the math was there and Bohr wasn't wrong. What I'm going to argue by the end of this video was that they were actually both right all along, because their arguments weren't actually contradictory. I mean, sure, Einstein's beliefs that the particles took on the info when they were separated is wrong, but I don't believe that this conclusion represents Einstein well. I could make a whole other video about this, but listen, sure, Einstein had a hit and a miss on this one, but don't we all? Really, if you want to accurately represent his view on the topic, it's mandatory that you look at his broad interests. In that sense, Einstein told us in one of his final intuitions that he felt quantum physics was fundamentally missing something. Couldn't point to exactly what it was, but something huge was missing. The theory was incomplete. If you ask me, we should be paying more attention to this point than we do, because, well, he's Einstein. We're playing the same game that he told us was broken before he died. And sure, his first attempt to find his golden egg didn't work, but that doesn't mean there isn't a golden egg. If anything, it means he died before he got to it. So I think that everybody who says Einstein was wrong about quantum is making a logical fallacy. An oversimplification, if you will. Sorry to be blatant about that, but just think about the deal here. If you're trying on clothing for a party at home, and then had to leave early for an emergency, that doesn't mean you picked the clothes you were wearing at that moment. It just means you were the last ones you got a chance to put on. See what I mean here? Clear as day, people. Okay, moving on then to my first postulate. I realized a simple way to fix this mess in one swoop. The idea is that we messed up when we said that reality is objective during the thought experiment. We were right about the fact that quantum states exist in both possibilities at once until they're checked, which remember we call superposition, but we fumbled the ball when we impulsively threw some determinism back in the mix after that. The state of the universe being objective is a very deterministic mindset, and doesn't really have a place in top tier in determinism. So my reasoning was that reality can only exist in the first place relative to some kind of observer placed within it. Without that, reality is meaningless, like trying to paint a picture without a canvas. It's really the combination of observer and observed that upholds reality. This means that reality changes if the observed is different, but also if the observer is different. So here's the solution. When Alice looks, the superposition only collapses into clockwise for her. But if Bob hasn't looked, then the particles are still in superposition to him and Alice with them. Okay, so in one reality is an Alice who gets clockwise, and in another is an Alice who gets counterclockwise, and both are neatly existing at the same time outside of Bob's view. That is until he checks and gets counterclockwise, for example, at which point both the particles and the version of Alice collapses into their states. But again, only to Bob's view. Alice could have checked years ago, but she sees both outcomes and makes both reactions at once to Bob until he checks. And this can be extended even further, you know. Bob, before he checks, is a different man with different experiences than Bob after he checks. I mean, sure, they're the same person, but that doesn't make them the same observer. So, I want to argue, compared to before Bob, the particles are still in superposition in the present after Bob checks. This is kind of intuitive if you picture how before Bob sees the world, because we picture the future as being somewhat chaotic and undetermined anyway. But this goes both ways, because for after Bob, in the now, who has found that he got counterclockwise, it turns out that he was always holding counterclockwise. So the particle never changed at all. Bob's reality did. Listen, I get that this sounds really convoluted, so to fix that, I decided to add some vocab into the mix. Introducing the ethos. The ethos is the central piece of this whole theory, to the point where I call the theory ethic reasoning. It's like the moment when you're learning about the theory of gravity that the teacher tells you the word gravity. An ethos simply is an entity which holds information. So I'm going to argue that a human has an ethos, just like they might have a mind or soul. In other words, added to your list of abstract concepts that you possess by existing. But more like a mind and less like a soul, it changes with time. So you may have the same soul now, argument aside whether there is such a thing, but you have a different ethos than yourself 5 minutes ago, and so on. It changes with every moment, or more specifically, every little thing you learn. And that's because, as far as a human is concerned, an ethos is the net presentation that holds all of the knowledge in the universe that is accessible to you. If something is accessible, then it's in your ethos. But if it isn't, then it isn't. It's much like a set in this way, but I think of it as far more organic. Whereas a set is like a bucket of stones, and ethos is like a bucket of water. That is, you can't describe the nuance and energy of reality just using a simple in or not in like a set. Or at least that's my idea. This doesn't mean you can't do math with an ethos, it just means you can't write down its contents or even visualize it as the set of its contents. I have a few solid intuitive reasons for this, but one is that an item might only affect an ethos in a specific way, but otherwise not affect it at all. Some properties do exist that give you no clues about the ethos and get no clues about them given by the ethos, but others give you only minute clues about the ethos, but otherwise are still random in alternate ways. For example, maybe you know a distribution is skewed one way, but still don't know how it will shake out altogether. In such an example, that property is in the ethos to the exact degree to which it affects it, but otherwise it is outside of it. So, in the example, that skew is in the ethos, but a further subcomponent of the property describing the random quantile on that distribution is not. And perhaps also other properties of it like the mean and variance. See what I mean in general then? It's less about the present in the ethos and far more about the effect on the ethos in terms of clues. Okay? Like, if I could derive a property given properties only in my ethos, then technically that derived property is also in my ethos. This then means that there are an indefinite number of ways to arrange the ethos, so the total presentation of all of them is intangible for it. Anyways, all of this complexity aside, you can perfectly understand the ethos just by looking at its base definition. Put simply, an ethos is the bucket where you store everything you know. So, to rephrase what I just told you, relative to Bob's ethos, before he checked his particle, the particle will be in superposition until the end of time, especially even after he checks. But relative to Bob's ethos of after he checks, the particle was always counterclockwise, if that's what he gets. Also, to extend this out, if Alice has already checked before Bob, then what she gets and how she reacts is in superposition relative to Bob until he gets clues and adds them to his ethos. Be it simply checking his particle or maybe getting a message from Alice or anything else like that before he can check. If the clue is in the ethos, then the superposition is gone. But for that ethos, and not necessarily alternate ethi, be it earlier ones or those of other people. And that's the nature of the first postulate. Written out, it says that anything may only be real relative to an ethos. In other words, reality exists only in relation to an ethos and never on its own. This may kind of be hard to wrap your head around from determinism land, but over in my breed of autistic people, it's pretty much intuitive. How about we call this the ethic pole of philosophy, which is opposite to the deterministic pole of philosophy. So, let's keep on translating, people. One thing I want to briefly mention here is that this concept necessarily splits the concept of time in two, which I call dimensional time and ethic time. So yeah, apparently they're different, and apparently we thought they were only the same thing. Listen, this is far from a comprehensive theory of time, which frankly I'm dying for, but hopefully it's a good next step. It's true that no human on Earth truly knows what the heck time is, and if they do, they're not telling anybody. Even the people who claim they know can be Socratic methoded to dust in 3 minutes tops, and that's including theoretical physicists too. If we really knew, it would make a difference as far as I can tell. But yeah, dimensional time is your classic time, like, 1980, 1990, and what your clock is telling you. Then there's ethic time, which we humans still categorize as time, but is fundamentally different. Ethic time, instead, is how far along the ethi you've ever inhabited you are. So Bob, after he checks the particle, is in ethic time, which is later in ethic time than his ethos of before. It's like if you string together all a person's ethi from birth to death and measure your depth along it. So Bob, from after he checks the particle, will trace dimensional time back and get past which hold all the information he knows now, but he'll trace his ethic time back and get less and less developed perceptions of reality. That is, if you trace ethic time forward 10 years, but then trace dimensional time back, there are less holes than if you trace ethic time backwards 10 years and then trace dimensional time forwards. Again, it has to do with the whole separate reality thing. Heck, we can't even be certain that ethic time has units of seconds, years, and so on anyways. It seems more likely, if anything, that it's more logarithmic with respect to dimensional time, but even that's probably an oversimplification. Anyway, so just keep this stuff in mind. Okay, moving on. I guess it was technically the first part I started talking about, but my second postulate is still second because, well, it's a natural next step after the first postulate. Also, I might have started it before the first postulate, but I finished it slightly afterwards. The finishing touch was a slight definitive shift in my mindset, which up until then was kind of ambiguous for me. My original mindset was to consider all the possibilities of what could happen outside the information on my ethos as existed on separate timelines, as if they were in separate buckets of which I could pick only one. I only really thought this because of our society's bias toward thinking of time as timelines. Thing is, though, I feel this doesn't capture the way that the ethos really functions in time. So my founding eureka for the ethos mindset was to drop the notion of timelines altogether, which hold information in separate organized universes, and instead realize that the more natural approach is for everything to be occurring right inside of our own universe with us. To be specific, let's look back at the trusty double slit experiment. When we're measuring which slit the particles go through during the test, of course we know they're just going to go through one slit, because not only do we have a recording of it, but we can mathematically reason that a particle going through one slit, and one only, will give that bright spot behind the slit, which sure enough is what we see in this case. On the other side of things, though, is that other scenario where we're not recording the particles. In this case, we get a pattern of a wave on the back, which we call an interference pattern. This, if you work out the right math, is a direct consequence of a very strange concept. Each particle went through not one slit, but both at once. Of course, this is super hard to understand as a human, but bear with me here. if the particle has a kind of ghost representation of itself at multiple points in space at once, all of which lie outside the view of your ethos, then it can travel through all of these points at once and even interact with itself in separate ghost positions. You then get this rapidly multiplying domino effect of the particle interacting with itself all across the space, and in the end, this leads to, mathematically, a wave-like pattern on the back plate where the bright regions are easier to get to in probability by the ghost sequence of the particle, and the darker regions are harder to get to. In effect, we don't have blocked off timelines from one another like determinism makes us believe. Instead, we have a stranger universe where all the timelines are unfolding right in front of you in the same spot, so the particles can interact with themselves in alternate states as if they are all in the same system, because blatantly, they are. It is from here that I efficiently had my first two postulates assembled. And from here, we get that second one now. Written out, it says that if an ethos is valid, then any given property will be in superposition relative to it if and only if it is statistically independent to it. Also, real quick, yes, I use the term statistically independent rather than not in the ethos, because I feel that this better grasps the nature of the ethos and how it interacts with properties. If a property of reality can change and leaves absolutely no clues to the fact that it changed in the ethos, then it's statistically independent to it. If it leaves any clues whatsoever, though, then it's not statistically independent, and instead is within the ethos itself to the exact degree that it makes a difference to it, if it gets changed. But that's just a fancy way of saying that it's either in the ethos or not, if you want to picture it that way. Like, if you don't know what's on the other side of a wall, then whatever it is can't give you information because, well, we just said you don't know. So therefore, it's going to be statistically independent to your ethos, and therefore be in superposition between all possible things it can be doing at the same time. Anyways, so if anything, this postulate is kind of the central axiom of the whole mindset, because through its specific consequences is my take on reality set up. Hopefully it's pretty clear where it leads in terms of figuring stuff out. In the case of the double slit experiment, if we know which slit the particle went through by observing it, then the slit is not in superposition relative to our ethos because of the second postulate. If, however, we don't know and don't have a means of knowing in the moment, then the particle will be in superposition between going through both slits at once relative to our ethos, and therefore, we get the interference pattern accordingly. Another cool consequence is the concept of the Feynman path integral formulation, which is at least hinted at by this mindset. If a particle can travel through two slits without being detected, then why can't it travel all throughout space as well? This is where we get the concept of an undetected particle taking every possible path at once and interacting with itself while doing so. It's because our ethos can't find out those properties about it, and so it does its dance accordingly, relative to it. Another weird consequence of the second postulate is the nature of Schrödinger's cat itself. Now, instead of the cat being alive and dead based on the decay of a random particle, we have a much simpler analog instead, which hopefully would have made Einstein and Occam proud alike. Instead of some complex string of causal relations to the quantum scale, now we explain the superposition of Schrödinger's cat by simply arguing that if you don't look in the box, then relative to your ethos, the cat is alive and dead at the same time if there was some risk of them being killed. As long as you don't have any clues, and you haven't checked the box, then the cat's well-being is statistically independent to your ethos. And if that's the case, then it's in superposition. Therefore, you've got a superposition cat on your hands. And yes, this also means that every person you know is in superposition between being alive and dead too, because there is a tiny chance that they have died since you last saw them. Therefore, meaning they have a tiny portion of their current superposition in which they're dead relative to your ethos. This is kind of freaky for a human to comprehend, which if anything might be part of the reason why determinism took center stage for societal metaphysics. For the record, I'm not suggesting you saturate your social life with the ethic mindset. Instead, only your metaphysics if you want to. I personally find it very helpful to keep the ethic mindset to my theoretical work, and then to switch my mind back to determinism on cue when dealing with society. Again, determinism is the driving metaphysical theory behind human society thus far for good reason. Frankly, we probably wouldn't have made it this far without it. So I personally get through the day by forgetting about the ethic theory when I deal with humans, and then remembering it again when I philosophize. But also keep in mind that just because it doesn't mix well with human social dynamics, the ethic theory still isn't antagonistic or anything. I would argue that it is much less selfish than something like solipsism, which stubbornly denies the existence of feelings and experience in other humans. Or, technically speaking, it argues you're the only consciousness in the universe. Okay? The ethic theory doesn't argue anything as troubling as this. Instead, it just argues that every human that you can't access the information of has all of their inaccessible properties in a superposition of doing everything at once relative to your ethos, and at the same time you're doing every inaccessible thing at once relative to their ethos too. You know, if you like the multiverse theory, I mean, multiverse theory has all that in it too, that, you know, people are doing multiple things in multiple states, except now instead of spreading it out to the multiverse where it's intangible, now we're pushing the whole quote-unquote multiverse back into our own universe. So, kind of weird, but it's what the ethic theory says, so yeah. So, in the end, we're all even in our superpositions anyways, and all that really makes a difference is who's looking. For this reason, I even think of the multiverse as more tree-like than people normally characterize it, but also not a binary tree like real trees. Suppose that if you add a property to an ethos, then you get what I call a child ethos of it, and then if you remove a property, you make its parent ethos. Because there are so many properties, there are a multitude of ways you can do this, but we can still approximate the image of this with a tree, at least kind of. Anyway, so that's the ethic tree. A tree which starts with an empty ethos, and then branches into every possible ethos using edges and nodes. You yourself would exist somewhere on the ethic tree at the moment. That is, until you jump into a new child ethos with your next waking moment of existence, which would be a child of your ethos on the ethic tree. And the same goes for me. I'm over someplace else on the tree, also descending down the hierarchy of things with each new bit of gained information. So if you and I are sitting in the same room, then it's almost like we're just different branches of the same ethos with our different examples of observation. So the multiverse is those around you. Anyways, you might be able to tell that this ethic theory still hasn't been finished yet, because the measurement problem isn't quite solved by these first two postulates alone. For that, we need the final postulate of the system, which is my third postulate. To get at this one, I underwent another thought experiment that I'll let you know about now. So I wanted to know just what made the quantum scale so different from our own scale. Everybody always seems to intuitively declare that the two are separate, but I mean, how can we really know that for sure? Already through my first two postulates, it seemed like something was missing in that department, right? So I set out to try and crack this, by imagining the classic double slit experiment played out on our scale. Imagine that we set up a large version of the double slit experiment on a soccer field. We construct two walls on the field, with one behind the other, and add two doors to the front wall. Then we round up 100 participants for the study and text two numbers to them, one after the other. First is the door that they're supposed to go through, and the second is a random angle for them to travel at once they get to the door. Or if we want to do a little bit of back-end math, maybe we just run the trig before and send them a number along the back wall to go to accordingly as their second number. Then there's me, standing with a blindfold on over by the bleachers on the edge of the field, waiting for the experiment to commence and finish. What can I expect to see when it's all done? My very first thought was to consider, at least for the sake of argument, what it will mean if we get an interference pattern on the back wall as if we were looking at particles going through two slits at once. I mean, look, I thought, I don't know which door each person is going through, so won't that mean that they're in superposition between going through both doors at once, at least according to the second postulate? But then there's an immediate problem here. If they do in fact definitively go through both doors at once, then what happens if I take the blindfold off at the end of the experiment, and then I go ask somebody which door they went through? They're going to say a door, of course. Oh, I went through door A. Or, oh, I went through door B. They're not going to tell you, I went through both doors at once in a quantum superposition. But now something weird happens. I've added the information to my ethos that they went through whichever door they said, and I've also added the information that they went through both doors at once, having seen the hypothetical interference pattern of them all. Well then, dang. That looks like a contradiction to me. But for that matter, I thought, what even is a contradiction in the first place? If if two things can happen at once outside the ethos but not inside? This is where the third postulate comes in. It's a way to generalize the concept of a contradiction and precisely name what it means. Now, I wasn't expecting my ethos to talk to itself from the future because that felt kind of arbitrary. So I wanted a way to crack this code that was completely independent from the flow of time. Again, the standard way I think to do this would be to involve time, but in my quest to find the ultimate opposite to biased determinism, I figured this was a necessary step to ditch that. So, you can think of my final result as being kind of like a checkmate in the game chess. And here's how I got to it. I figured I start with some trial and error for the third postulate, see how they perform, and then update it to make it better. The longer I did this, the clearer the final result should become. So let's look back to the double slit experiment for inspiration. In the case of the double slit experiment, we know that if a detector is present, then the interference pattern goes away. This works like clockwork for every example of the experiment, so let us postulate that the recording of the detector and the loss of the interference pattern must, physically, always go together. Another way of putting this is that an ethos, where the detector is recording, but the interference pattern is also present, is an invalid ethos. See what I mean? It never goes that way, so we'll have to call it an invalid ethos because of that. All that's left then is to find out why. One particular thing that comes to mind straight away for me is the fact that once the detector is running and has recorded the information of those particles, then that information can never be deleted. So in other words, it's in the universe forever. Even centuries from now, it would still be possible to find that data. And if we choose not to, then centuries after that we still could anyways. The point of the matter is that even if under no conditions are we guaranteed to look up that data, under all conditions, we definitely can. So this is one fundamental property here that I think we have to take note of. In the case of the recorder running, we can always look up the data and later find which slit the particle went through. And more importantly, which slit it didn't go through, which itself is the data point that clashes with the side of the interference pattern, because remember, the interference pattern is telling you that the particle went through both slits, so, it kind of didn't not go through one of the slits, right? Yeah, you see what I mean. So, perhaps then, we can start to build the postulate even from this. The possibility of contradicting an ethos is just as dangerous as the actual act of contradicting an ethos. If you need a few more conditions to get rid of that possibility, then those conditions might as well already be part of the ethos, because the fact that the ethos is valid itself is part of the ethos. So, then the idea boils down to essentially this. If there's no way to avoid the possibility of a contradiction, then the ethos is invalid. Now, we just need to translate this statement to ethic terms. Possibility seems like the statement of a child ethos, as does the word avoid. So I'd write it this way. If all the children of an ethos possess their own child, which contradicts the original ethos, then that original ethos is invalid. It's a two-generation argument, and I think it does the trick. We're also assuming here that each child can only add more properties to his parent, instead of overriding and inevitably contradicting his parent. This way, the only second-generation possible contradictions have to come from additions to the framework already established, instead of going back and changing it. The last step is to put this postulate in the form of the others by stating what should happen instead of what shouldn't. We can do this by use of the logical contrapositive. For those of you who know what that is, great. For those of you who don't, it's just a fancy trick of saying how if A makes B happen, then if B doesn't happen, then A never happened to make it happen. So what? Not B makes not A happen. Get it? Hopefully I explained that well. Anyways, so here's the finished third postulate. If some ethos is valid, then there exists a child ethos to it for which every one of its own child ethi strictly do not contradict any of the properties of said ethos. Awesome. And that's everything we need to solve the measurement problem as far as I'm concerned. Let's look back at that pesky double slit experiment and give it an official solution now by filling in the blank that is the measurement problem. Thing is, we're going to want to explain both scenarios, detector on and detector off, using the same framework because, isn't that how life is anyway? Let's start with detector on, because that's a more pressing one at this moment in history. First of all, we have to apply the third postulate over and over again to weed out any invalid ethi that are child ethi to our ethos in question. We know that those ethi can exist, so our ethos itself becomes a combined total of all the ethi left over. And in effect, it's added to it that at least one of them can happen, or by the second postulate, our ethos is the combined superposition of them all. Okay, the next step after determining this composition of our ethos is to work our way backwards and apply the second postulate to everything else, determining what's certain and what's in superposition. With this, we have painted the basic picture of reality. So, let's give it a shot here. Pretend you're the experimenter observing the double slit experiment, and you've just fired an electron at the two slits with the detector running. At this point, we can consider breaking your ethos into two different child ethi, one in which you see an interference pattern, and another in which you don't. So let's test both of them and see how the third postulate goes. Now, if you see the interference pattern, then that just means the electrons went through both slits at once, and so no matter what you do, every child ethos of your own will allow for the possibility to gather the information from the detector, and thus see that the particle went through one and only one slit, as according to what the detector will tell you, hence the gained information. Thus, there does not exist any child ethi of your own which have child ethi that don't contradict yours. A bit of a mouthful, but if you draw the logic out, you see it legibly breaks the third postulate, so that ethos would have to be invalid. Therefore, the only possible child ethi of yours is one in which you don't see the interference pattern, or in essence, your ethos is equivalent to an ethos in which you don't see an interference pattern. Okay, so what have we just said? We said that if you're the experimenter in this situation, and your child ethos in which you see the interference pattern and the particles go through both slits at once, we know that that's an invalid ethos, then what does that leave us with? Well, it only leaves us with an ethos where the particles don't go through both slits at once. So, that's the remaining ethos. We're in superposition there. There you go. Now, we know from this that, lo and behold, if the detector is running, then the particles are in superposition between going through the first slit and not the second slit and not the first, and I guess neither too. But they're not going to go through both at once, otherwise we invalidate the third postulate. Yeah, so this specific part is admittedly a bit tricky for the human mind to process, given our visually oriented view of the world, and for that reason it took me a while to really comprehend it, so bear with me here. The idea is that even though the particle didn't go through both slits at once, that doesn't mean it can't be in superposition between going through A and not B, with going through B but not A. A and not B plus B and not A does not equal A and B, and no knots. It's actually kind of simple if you picture it in discrete permutations. Check this out. If it goes through a slit, we light it up, but if not, we don't. So we have four basic scenarios. No slits are gone through, slit A but not slit B but not slit A, and slit A and slit B. Look at this. When we invalidated the ethos where it goes through both slits at once, when the detector is running, all we did was take out the last case here. But that doesn't mean we get a specific case after that. Instead, we're left being in superposition between the other three cases like this. That's it. Just try and imagine this happening seamlessly and without the use of a weird breaking up diagram aid like the one you're seeing. It's just how nature works, but I know it's really weird. Anyways, we might even set the backplate to mark where every electron lands, in which case the act of viewing it collapses the superposition of where it lands relative to your ethos because, second postulate, it's now seen, it's now observed, it's now known to the ethos. No superposition. So, if you do look back onto that plate and see an electron blot spot out there, then now you can calculate simply what the probability of it going through either slit A or B is. And it won't be even unless it's somewhere perfectly in between them. Point is, this didn't truly fall out of superposition until you legitimately access the detector, at which point you clearly see what played out. But until that point, it was in superposition between, slit A and not slit B and not slit A. That, my friends, is the ethos for which you know which slit it went through, because the ethos before you checked the detector had it in superposition between going through one slit but not the other in both ways. And again, remember the same system where it's always in superposition relative to the before ethos and never in superposition relative to the after ethos because, first postulate. Anyways, now let's check out the alternate case where the detector wasn't running. In this case, it's a bit simpler, but perhaps less obvious for it. We use the second postulate itself to invalidate potential ethi here. Normally, we use it to find when the superposition is happening, but we may just as well use it to invalidate ethi where the superposition doesn't happen when it should. See what I mean? In this case, we make direct use of Heisenberg's uncertainty principle. The principle tells us that a particle's position and velocity cannot be measured at the same time. This is really huge because it's basically a safety for subatomic particles falling out of superposition relative to any ethos. I wouldn't be surprised if the very stability of reality depends on it in some way or another. Because of the uncertainty principle, we can determine that if we don't measure which slit the particles went through on the spot, then for the infinite future onward, we have no way of accessing it again. Put more concisely, and so we don't hold on to the bias of linearity of time, no child ethos of your own, when the detector wasn't running, will contain the slit of travel of the particles at the time. Thus, it has to be in superposition, so some weird unexplained state of it going through one but not the other doesn't cut it. Such a thing would make statistical independence, but not superposition relative to your ethos, or in other words, it's invalid. And that's just another contrapositive argument there, at least relative to the second postulate. Therefore, we can knock out those two child ethi as possibilities, in total leaving your ethos as equivalent to that containing a superposition between the particles going through both slits at once, with none at all. And sure enough, there's your interference pattern, people. Last but not least, it's time for some real-world applications. I'm still only in undergraduate mathematics for the most part, so I'm not exactly an authority on it, but I have a slight intuition that we're nearing the next major revolution in how math is done, on par with the origin of calculus. I told you what Heisenberg's uncertainty principle does to the ethos, but frankly that applies to any old uncertainty principle. So for that matter, we might ask how this interacts with mathematics. The first thing we would need to work out is the precise nature of derivations in the ethos. My suspicion is that the concept of derivation is due to go away of time, and be two separate concepts that we've always been confusing for one, but it's probably slightly different than that. Regardless, I think it would be safe to conjecture that the quadrillionth digit of pi, or wherever we are right now, has a superposition following a uniform probability distribution relative to the unknowing ethos. It's either that or pi in its full with the rest of math is fully encoded with all its infinite storage in the ethos at birth. But that seems less viable to me. But anyways, let's suppose that we do crack the code of this, be it biological, physical, or other, and now we can apply the ethic mindset to math. I think a lot of cool things are going to quickly happen there, like solving the Riemann hypothesis, generalizing p-adic numbers into a periodic theory of infinity, and maybe making problems like the four-color theorem a lot simpler. I know it's wishful thinking, but a guy gets to dream a little, you know? When we sum the numbers from 1 to infinity, for example, we get negative 1/12. We can just accept that that's absurd, but we don't have to. We invented addition 4,000 years ago to count sheep and grains. But maybe only now are we catching up to the fact that our trusty system was just a speck on a bigger concept. Maybe numbers themselves are some kind of rough superposition collapse of a deeper pattern. So when we collapse one pattern to make number 1 and number 2, that makes sense. But when we collapse the whole of the natural numbers to get negative 1/12, only then are we shocked. See what I mean? Like, why does the sum from 1 to infinity get negative 1/12, but the sum from 0 to infinity get us 5/12, which is larger by exactly 1/2, the arithmetic average of 0 and a unit. It's like the average of counting one more and doing nothing at all, or something like that. The fact that infinite 9s repeating to the left of the decimal is algebraically equal to negative 1, just so weird, but kind of clearly hinting to something massive and fundamental looming in the clouds of determinism. And yeah, I'm fully aware that at this stage of it, it just sounds like, you know, like I said, wishful thinking, almost craziness, but I don't know. I mean, this whole uncertainty principle stuff is really promising, so what better place to take it than math? I'm not sure how it's going to get pulled off, if it's going to get pulled off, if I'm even onto something at all here, but who knows? Maybe something might happen here. So, yeah, this is basically all I've got for you today. I'm telling you, when I was writing my script, it seemed a lot more simple. But now that I'm actually reading out loud, shoot. Okay. I mean, yeah. Hopefully this is all intuitive, at least to an extent. You might have to give it a few watches. I'm telling you, from what I can tell, it's all cohesive. Like, it is. I tried to do with indeterminism what the human mind has done with determinism, right? Like a full theory that pushes up against everything and gives you an entire picture of reality. So in this video, I tried to give you the complete rebuilding of reality in an indeterministic world. Did I pull it off? I don't know. Hopefully, it does solve the measurement problem. It does solve entanglement stuff. Does it solve quantum gravity? Don't go there. I have no idea. There's a lot to do. But the point is, thank you so much for watching. And you know what? Keep thinking. Keep dreaming about science and art science. And thanks for watching.